So according to the problem, car A and is running at 35 miles per hour towards car B, and car B as well is running 50 miles per hour. Okay, so we now have here an example problem of application of differential calculus. So let's start. So we have two cars start out 500 miles apart. Car A is to the west of car B and it starts driving to the east at 35 miles per hour, and at the same time car B starts driving south at 50 miles per hour. So after 3 hours of driving, at what rate is the distance between the two cars changing? So is it increasing or decreasing? So before we start solving this problem, the first thing that we are going to do is to create a graphical representation of the problem for the purpose that we can easily visualize the case scenario. So let's start and create our graphical representation. So let's set up first the orientation of our graphical representation. So we have here the north, south, east, and west. So according to the problem, car A and is running at 35 miles per hour towards car B, and car B as well is running 50 miles per hour going south. So as you can see, so ito yung simulation or ng kanilang movement. Alright, so the objective here is we are going to determine the rate of change between the distance between car A and car B at time is equal to 3 hours. So let's say ito yung instant where t is equal to 3 hours. So before we conclude that this graphical representation is the correct representation of this problem, we need to verify first. So how are we going to do that one? So by the way, this distance, we will represent this as the variable z. So we are looking for the rate of change of z with respect to time. So we have here dz over dt. And then, according to the problem, at time is equal to 0, the initial distance between car A and car B is 500 miles. Alright, so now to verify our graphical representation, let us ask ourselves, during the instant of 3 hours, has car A, this one, has it already crossed the line of path of car B? Alright, so how do we answer that question? Well, it's very simple. We will calculate the total distance traveled by car A during the period of 3 hours. So by doing that, we have determined that the total distance traveled by car A is 105 miles. So basically, it has not yet crossed this line of path of car B because it's less than 500 miles. So at this point, we can now conclude that this graphical representation is the correct graphical representation of this problem. Alright, so the next step is how are we going to calculate this rate of change between the distance between car A and car B. So first, we will convert this graphical representation into a geometrical figure shown here. So we can represent this one is a triangle. And then let's set this side of triangle is the distance traveled by car A, and let us represent that as x. And this side of the triangle corresponds to the distance traveled by car B, and let us represent that as y. And then the distance between car A and car B, we represent it as z. Alright, so the objective here is we are going to calculate the rate of change of this distance. So as x and z is moving, so this distance x is changing over time, diba? Alright, so how do we solve this one? So the first thing that we need to do is, first, we will create a relationship between these three variables. So what do you think is how can we create a relationship between these variables? So as you can observe, since this is a 90-degree triangle, then we can use the Pythagorean theorem to create a relationship between these three variables, diba? So we have now this relationship. Okay, so the objective is to calculate the rate of change of z with respect to time. So basically, all we need to do is we derive this equation with respect to time, diba? So by doing that, so we will obtain this equation. So how is this equation obtained? Simply using the power formula, which I have already discussed on my previous video, diba? So power formula, 2z raised to the power of 2 minus 1. So that's 2z dz over dt. dz over dt because we are deriving all this variable with respect to time. And then this one, we have 2x dx with respect to time. And then this one is 2y times dy over dt. Okay, so now we're almost done. So we are trying to solve for this expression. So by looking at this equation, let us check first which of the following data is already available. So from the given, since the rate of change, take note, the rate of change of the distance with respect to time is simply the velocity, diba? Or the speed. So basically, we already know dx over dt and dy over dt based on the given, diba? The car A, this one, the rate of change is given as 35 miles per hour. And we set it as negative. This corresponds to the direction of car A. So as you can see, as time increases, car A approaches to 0, diba? So this is the origin of our Cartesian plane here. So it is approaching to 0. So basically, it is decreasing, diba? So that's why it's negative 35 miles per hour. And then now let us continue. So if we try to observe here, we know this variable and this variable, so we need to calculate the value of x, y, and z in order for us to calculate this expression, diba? So how are we going to calculate these three variables? Alright, so take note, we are evaluating the rate of change of z with respect to time at the instant of 3 hours. So we will simply calculate the value of z, x, and y at time is equal to 3 hours. Alright, so at time equals to 3 hours, the value of x, this one, is equal to this expression. It's 500, which is the initial distance from here, minus the total distance na gi-travel na x during the 3 hours, which is 105 miles. Diba? So that means after 3 hours, the remaining distance, this distance from this point until this point is 395 miles. Okay. Next is the distance traveled by the car B. So that's simply 5 miles per hour times 3 hours, and that is 150 miles. So using this equation, we can now calculate the value of our z, which is 422.52. So as you can see, we now have the value of x, y, and z, and also dx over dt and dy over dt. So only single variable na lang ang remaining na unknown dito sa expression na to. So we simply plug all those value and then we calculate for the value of dz over dt, and that is equal to negative 14.97 miles per hour. Nice and easy. So as you can see, the answer to this question, the rate of change between the distance of the two cars changing is negative 14.97 miles per hour during the instant time is equal to 3 hours. So the question, is it increasing or decreasing? So as you can see, it is negative, so basically it is decreasing. Okay. Nice and easy. So I guess that's all for today, and on my next topic, I'll be answering again more exciting sample problems. So you can comment down if you wanted to request some example problem so that I can assist you on your study. And I guess that's all for today. Engineer Kaz is signing off. Bye bye, guys.